I'm recording this, right? And what I would like is I would like for all of you to look at each other's Jamboards, and then I would like you to lead this meeting. And basically, remember, your goal is to learn from each other, get consensus, and get clarity. So if there's something you see you disagree with, push back. If there's something that you see that you don't understand, ask questions, right? And remember that at the end of the day, this is really practice for your capstone, because this problem should look very similar to what you guys have to solve for the capstone. So go look at the Jamboards, and then let's have a conversation about what you see. So does anybody see something they like? Does anybody see something they don't understand? Who's ready to talk? And what I'll do is I'll start sharing my screen actually, so that we can see the gems. We can all talk about the, when you see something that you like or that you want to talk about, why don't you voice it, and then I can go to the Jamboard for the sake of the picture, for the sake of the video. So anybody has anything that they see, that they like, that they understand, or any questions or anything? Question to the group, questions to me, questions to whatever.
Well, something I noticed is that on slide 3 and 4, like A and B, like the dots are aligned together on at like second 5.
Mm-hmm. Should they?
I think so, because that's like where they're at like the same position at the exact same time.
Any other thoughts about slide 3 from anybody else?
For me, room 3 and 4, the only ones that show up. The rest are just blank. Like room 1, I'm on whiteboard meetings number 8. Room 1 is just blank. Room 2 is just blank. And then like room 5 is just blank.
Oh, I'm sorry. I'm looking at they may or may not have uploaded theirs to the whiteboards. But if you look at the Jamboards, slides 1 through 5 have information.
Right.
I'm also sharing the slide with you, right? So, yeah, Tim.
I think for room 4, like the bottom dots, there's 1, 2, 3, 4. At 5 seconds, it's at 5, but for the second one, at 2 seconds, it's at 5.
So what are you saying?
So like maybe add some dots at for the top section before, so that it's both 5 seconds when they meet at 5.
Can
Wait,
somebody,
can you please like explain that again? I just got
Okay.
very confused.
thank you, Tara.
Well, is like, isn't like the first dot starting at 0 seconds? Oh, so if the first dot starts at 0 seconds, then if you see like the top line, it would be 0 seconds, 1 seconds, 2 seconds when it reaches the 5 mark. And then for the bottom line, it'd be 0, 1, 2, 3, 4, 5 seconds when it reaches the 5 mark. So I'm saying like you should probably add some dots before like the 0 seconds on the top line so that they will like match in time.
I think what he's trying to say is there's only so much like room that you have, and there's only so many dots you could put down. One of them travels more distance, so you need to have the one that travels a less distance after, so it doesn't just like end super early. Yeah, like because if I started the like one with the less dots on 0 seconds, it would not even get to the 5 second mark because it's so small, while the other one reaches all 10 seconds.
Thoughts about that?
Well, I thought that Timothy was saying that the top line is showing that the person starts moving at 4 seconds, but he really starts moving at 0.
Yeah,
And
that's
they should
what
have dots at 0.
basically.
Hey, can we just, for sake of clarity, can we, that bottom line, 0 to 10, what's the unit on that line?
I believe seconds. So like 0 to 10 seconds, because they meet up at 5 seconds.
Wait, isn't that supposed to be meters?
Yeah, I think it's supposed to be meters because each dot is a second.
Oh yeah.
Do we agree? Do we disagree? Where are we at?
Well, for my group, me and Lucian, we didn't put any units there at the bottom, so we just
So
said that each
you're on
dot.
3, right?
Yeah,
Okay. So can you
said
explain
that
to us?
each
Can you explain what you did?
we said that each dot is 5 seconds. So the first dot would be 0 seconds, and the next dot would be 5 seconds. And since they meet at 5 seconds, and it's like in the middle of the graph, we just put the second dots for each of them in the middle.
So can we have clarity? Is that scale on the motion map, the scale at the bottom, is that in meters or is that in seconds? Harry, what do you think? So is it board 3 or is it board 4 when they're saying it's in seconds?
So well,
By the way-
board 4 is in seconds because they have an M. That I assume that means that it's in meters for board 3.
Board 3 is as an M. So yeah, board 3 thinks it's in meters. Board 4 thinks it's in seconds. So which one is it?
I'm not sure. I think it'd be meters, right? That would be the correct one.
Do we agree on that?
That's what I think.
Marla, what do you think? Sorry for putting you on the spot. Yeah, the only Marlo we have, our national Marlo.
I mean, it could be meters, but it could also be miles. I'm not really sure which one.
Yeah, it's in meters, right? A motion map, what you have is you have the line along which things are moving, and you have, right? That's in meters. And then the dots represent the seconds, right? Because the dots are in equal intervals of time. So the first dot is always at 0 seconds. The second dot is always at whatever the interval is later. So Natalia said, well, it's always one every second. Every example we've given you so far had a dot every second. But It could be that you have a dot every 0.1 second, every 100 seconds, every 5 seconds, every 1 minute, every 1 hour, right? In your in the capstone project, everything is in miles per hour. So maybe your dots are going to be every hour, maybe your dots are going to be every 30 minutes, maybe your dots are going to be every minute, 10 minutes, whatever. But the dots are every intervals of time, right? So in 3, what's interesting is in board 3, what's interesting is that the right, the first dot is at 0 seconds. So, and this is why it would be advantageous for all of you to indicate that. So this one should have something like this is 0 seconds. This is 5 seconds, right? This is 0 seconds. And this is 5 seconds. And they happen to meet at the same spot, which happens to be X meters, whatever X is, right? We don't know. We don't know because we don't have a scale. But what's cool about the drawing that they did in F here in board 3 is that how did they show that one was going faster than the other? First of all. Yeah, Tara.
They made the top lines a lot longer.
Yeah, they made the arrows longer, right? Remember, the arrow represents the speed. The arrow represents the speed. So they made the arrow longer. Longer arrows means faster speed. Okay. How do we know that the two intersected? Yeah, Tarsil?
They fall on each other at the same on the same line. Their points are both on top of each other.
Yeah, they're at the same position at the same time, right? And that's really important. They're at the same position at the same time. Two people can go over the same street, but if they're not going on the same street at the same time, they're not intersecting, right? They just happen to be on the same street. But if they're at the same street, at the same place, at the same time, then they're on top of each other, right? So any questions that you guys have about this problem? About how to do the motion map, about how to interpret the motion map, right? So to go back to question 4, right? What I believe Tim's thing was saying is that if this is 0 seconds and this is 0 seconds, right? Then, and I don't know what the time increment is on those things, but let's say it's 1, this would be 1 second. This could be 2 seconds, right? And this would be 1 second on 4, and this could be 2 seconds. And this would be 5 seconds. And therefore, what's clear here is that both A and B happen to be at, this would have to be in meters, right? Both A and B happen to be at 5 meters together. They happen to be at 5 meters together, but one is at 5 seconds and the other one was there 3 seconds earlier. Actually, what's interesting is that you have overlap here, but you also have overlap at 4 meters, right? It just happens that one leaves 4 meters at the beginning of the experiment. The other one gets to 4 meters after 1, 2, 3, 4 seconds. Does that remind you of something in the problem? In the capstone? Is there an analogy between this and the capstone? Did somebody start running early or from further ahead? Yeah, maybe. Okay, so anyway, food for thought. Okay, so we're gonna stop share. I am gonna stop recording.